So welcome to this day's lecture. So today we're going to talk about data visualization. And the main tool we're going to use is a software called ParaView, complemented with some Python modules to generate files that you can use in ParaView. So I will go through a bit overview information on ParaView. So these are slides that are available on the Kitware homepage, the software developers of ParaView. ParaView is has a long history. It started in 2000s and is based on a library called VTK for data visualization, but it's packaged in a more user-friendly way. So we're going to do a short introduction, and I will go quickly into actual practical using ParaView. So I will stop at some point in the slides to go over and use the program for real. So what is ParaView? So it's an open source, very scalable multi-platform visualization application. So ParaView can be used on a Mac, it can be used on a Windows machine, on a high-performance computing. It can even run over multiple nodes if you want that. So it supports distributed computation to be able to process large data sets. And that is interesting because much of the data visualization requires you to do a lot of computational work to actually slice your data to create the surfaces for the visualization. That can be a quite heavy computational task. The program also has a very flexible and intuitive user interface. I would say that with a bit of parenthesis because it's sometimes it can be daunting before you kind of get the basic concepts of how the visualization in ParaView works. It's very extensible. It has a modular architecture. By that you mean that you can actually add plugins to the software to add functionality to it. It already contains several hundreds of built-in plugins for different algorithms, for filters, for data loading of different data formats. And it's open source using BSD license, but you can, of course, get commercial maintenance and support as well. Here are some of the examples that you can actually do with this software. So it can plot streamlines for computational fluid dynamics. It can plot finite element meshes, and very many of these algorithms for scientific visualization is built in. So because VTK in the bottom is this kind of main library and it has all these algorithms, then ParaView also can do a lot of these algorithms. So it's used very heavily in academia and government and also commercially at companies. And it's downloaded extremely often. So it has got a lot of choices for best technology. And you can see here that visualization is a very important tool to understand your data. And you can use ParaView for almost any size of data you have. So here are some noteworthy data sizes. So you can see here already in 2005 you could do 6 billion structured cells, 250 million unstructured cells, and so on. So it can do a lot large. It can process large data and produce visualization for that. So this is the architecture of ParaView. So on the left top, you see the ParaView client. That is the software that we're going to use in this course. The ParaView client also comes, when you install it, it comes also with a special version of Python that has all these libraries built in. It's called PyVTK. So that is a standalone application that you can run special Python scripts that uses the libraries of ParaView. So I will illustrate that how that works as well. There are some other applications, but we will focus on the two left here: ParaView client and PyVTK. Under this, it's built on Qt widgets, which we will also go through in this course later on. And it has Python wrappings that wraps the functionality in Python modules that you can use. So the application, all the visualization you create, you can export in Python format. So you can run them again and recreate the visualization exactly as it was before. And that is because the application is very heavily built on Python scripting. There's a ParaView server that is used to kind of distribute ParaView. If you have multiple nodes, you can run ParaView. The data processing can be run on multiple nodes. And underneath that is something called VTK, which stands for Visualization Toolkit, which is the underlying library that everything is built upon. So VTK is a C++ library. So you can, if you're interested in C++, you can do most of the visualization using that library. And underneath that library, there are multiple technologies. On the left, you have OpenGL for hardware accelerated graphics, MPI for distribution. So if you run on multiple nodes, you can use MPI, message passing interface, to actually do parallel visualization as well. And there are some other libraries here as well, but those are the most important in this course here. We will not be doing MPI, so that is something you have to experiment on your own, but you should know that it's available at least. It has been developed for a long time, so it's a very mature application. It has been around since the 2000s. And we are currently at 5.9, and it has been updated, so perhaps that doesn't say too much, but it supports modern OpenGL features. So OpenGL 3.2 is a quite modern version of OpenGL, which has a lot of performance improvements that makes possible to visualize even larger problems. Yeah, this is the funding model. So there's a lot of parties that are investing in the development of ParaView. So big labs and also in Europe that supports the development of this. And it's also part of the exascale computing project. So the goal is to kind of enable you to visualize really large data sets with this tool. So what is visualization? So I think this picture illustrates this quite well. So on the left side, you have your results from for your visualization runs or for your data in some form, and you need to kind of get a grasp on quantify it in some way. So the data visualization goes from this table of data to something that you can interpret with your own eyes. So this left side is a wind tunnel analysis of a space shuttle, for example. So you can see the pressure lines, you can see the flow lines. So that is kind of the base of it. ParaView and VTK has several built-in data types for visualization. And these are, you have a uniform rectilinear data structure, so a structured kind of grid type with a fixed distance between the cells. You can also have non-uniform rectilinear. That means that you can change the distances between the blocks using some kind of rule. There is also curvilinear data. And you have polygonal data, which is kind of polygons connected together, either chords or triangles connected together to form a mesh, which you can then put data in. And you also have unstructured grid, which can contain any kind of cells and data combined together. And all of these data structure can, in these, you can provide data either both in the nodes. Let's see if I can annotate here. So you can have data on the nodes here. You can also provide data in the cell. So if you look at here, for example, here, you can provide data as a cell for each element here. So in different ways here, and that you can provide as well, and that can be used to color the model, or provide visualize in certain ways, and it's also used to interpolate different visualization as well. So you have to define your geometry, and then you have to find your data that you provide. And each structure can have multiple data points that, so you can have data scalar values here, you can have vector data, you can have multiple data values at each point in the data structure. There are a lot of material for learning more. So this course will only provide a kind of basic introduction to ParaView, and then there is a lot more material available on the web. So the ParaView site here has a ParaView guide. There is also a lot of tutorials here. So if you have a problem for that needs visualization of some kind, it could be good to go into the tutorials, and there you can find different visualization types. So the webpage is paraview.org. There you can also download the application for free. And also there is a lot of help available in the program directly. So you can all this material is provided when you install the program as well. I think I will skip the slides now and switch to ParaView. So this is the ParaView, the main layout of ParaView. So I will try to just. So you have the normal toolbars on the top here for loading models and so on. But the main kind of functionality of ParaView is actually inside. Oh, sorry, strange drawing. Main functionality is in this part of the application here, and it says pipeline browser. So all visualization is based on something called a pipeline model. So you start with your data, you're reading your data into the pipeline, and that is the first point in the pipeline. And then you apply filters to that pipeline, add properties to that, and change, and that will build your visualization. And every object you provide in the pipeline has properties here you can select and change in this part here. And then when you're done here, the data will, the result will be displayed here like either in 3D, but it's also possible to do 2D here as well. So that is the main functionality. So what you also have is that, so ParaView usually use existing data to visualize things here. So there are several sections here. You can create data inside ParaView as well, and that is called sources. And there is a lot of different things you can generate here. So you can generate cylinders, spheres, and anything here. It's available here in this menu. So alphabetical is every object, and then there is annotation, so you can do 3D text, data objects, geometric shapes. So I will just create a sphere here. And you see now in the pipeline, you see that there is a sphere, but there is no sphere on the screen. And the reason for that is some of the things that you load can be quite huge, and you don't want it to start processing immediately. You want to kind of control the visualization and set the parameters before you visualize it. So if you want to see this sphere, you have to click on the green button here, which lights up when you add something to the pipeline, press apply. And then you see here now that you have a sphere. And you can rotate this sphere using the mouse here. You can also see here that the properties windows now actually changed. So before it was empty like this, and now when I click on the sphere, it shows a lot of data here. So, for example, I want to do increase the resolution of the sphere, for example. Then I can click here on to set, let's say, 16 by 16. And then you see again here, nothing happens again. So now you need to click apply again. And now you see that the sphere has a better resolution. By default, when you create objects, it will visualize them using something called surface visualization. And you can change the visualization model of this either by directly on the object here, or using the toolbar up here. It's the same functionality here. So if you want to see what a sphere is constructed of, you can just go surface with edges. And now you can see here that the sphere is built up of smaller triangles here that makes up the visualization. And now we have colored, the sphere is colored by the default color, which is gray. You can also select the color here. It says solid color, and then you can just select here, I want a red sphere. Now my sphere is red. I can also switch to wireframe so I can see only, not so good color as here. We make it white here. Now you see the wireframe model. You can see only the points as well, so the points that make up the sphere. And there are some other things here, but we don't get to now. But surface is a good choice. And if you want to control if you want to see the resolution of your model, it could be sometimes good to have surface with edges switched on. You can also control here, and that is standard for all the objects in ParaView, that you can control the opacity. So for example, I can do the transparent object like this, so you can see through. And sometimes it can be good to do transparent objects to illustrate some parts of your model, but you want to enable the user to see through that object so that it doesn't obscure the visualization. You can also make it a bit more, change the lighting model here so it becomes more shiny. So you see here there are 4 lights shining on this object here. You can switch on data axis here to show the scale and axis of the model here. You can add that to each of the objects or to the entire model as well. Here, and there's some other. You can also change it's possible also to change the edge color here to something else. So if I want to have white edges here, it's also possible to do that. ParaView doesn't really have a file format. You can save the state of your visualization, but when you're done with the visualization, you can save it as a state file that kind of loads the different things that you loaded in. But if you want to start with a new model, you click on there is a reset session button on the top, which you can use to kind of reset the model, and it removes everything here. Takes a bit. So what I'm going to do now is to show you how you, with an existing model here, what you can do with ParaView and the basic principles. And you can do this yourself. There are several data sets available with ParaView that you can use, and they are provided in the main ParaView program in the examples folder. And we will be using the example called disk out ref x2. That is a cylinder with a hole in it, and there is a fluid in it, and there is a heater that heats up the fluid. So see here, and now you see I loaded the model and nothing happened now. You see the green button lit up, which means that I can apply that and visualize it. But I want to make sure that we get all the values here. Now you see here in the model, there is a lot of data points available. So you have stuff that I don't know it, but there is temperature and speed. And what I can do is just click on the top here on the variables to make sure that everything is loaded when we visualize. So let's see what happens if we do apply here. So now you see here that we have a cylinder with a hole in it. What we can do directly now is, by default, it doesn't draw anything here, so it just shows the block colors here. We can change here to, let's display the temperature here. So we click on the data variable we want to display. And now you can see here that it displays temperature, and you can see that there is a heat source here in middle here. So, but this is not very good way to kind of look inside a hole here to kind of see the visualization. So one thing we could do now is to make a cutting surface to cut it in half, and so we can see inside. And you see on top here there are several filters that you can apply. So we want to do not a slice, because slice will only take a section and display the surface of that plane. So we want to cut the model in half. So we do clip. Now you see here that you have it shows you a clipping plane here. And you can control the clipping plane in the properties section here. So you can put the origin here, and you can change the normal. You can also move it back and forth here interactively in the model. I will not do that because I want it to be scaled in half here. And you can change which direction you want the cut to be. So in this case here, you can cut to the different directions here, but we keep it standard here. And when we are done, we click apply. And now you can see here that we click, so now we can see inside the model here. So that there is the fluid has been heated up here. And now you also see, if you look in the top left here, you can see that the data model here is there is an eye here that has been shut here. That means that every time you do add a filter to this visualization, the previous step will be hidden. If I click on this eye here, you can see here now that it displays the entire model again, and that is not optimal. We want to be able to see this one here. You can also change the color scale of this. So if we go down to change here the color, so now we are plotting the temperature. We can change this to on the right side. Now you get the color scale editor here. So by default, this is the default ParaView color scale. You can press the button with the small heart here to change to different display modes here. So now you see here that it looks a bit different, and you can change here to different color scales here. You also see that the color scale indicator also changes automatically. We will keep let's see, Inferno sounds good. We'll look like this. So now we want to do some more. We want to visualize the flow in the model. What you can do then is you can do something called streamlines. And then we first thing we need to do is to there is this called stream tracer filter. And every time if you want to do a combination of visualizations, I usually always click on the data model first. So and then I want to add a visualization to that. So otherwise, if you have clip selected, it will do the visualization applied on that sub volume. So it will do the visualization in the clipped volume. But now I want to see the flow lines in the entire model and have the clipped model as a background. So let's see here. I click Stream Tracer, and now we want to have the streams coming out in the middle from a sphere. So we change from line to a point cloud like this. And this sphere here illustrates where the particle will be generated from. So it will be released from inside this sphere. So if we want to have it, we have to cover the entire model, we have to enlarge this sphere a bit. So let's see here if we can change this to 3.5 or 4. Like that. And then you can see here that it will generate 100 points that it will trace from this point. You can just run it and see what happens. So now you see here that it released a lot of lines here, but the thing is that we can't see them because they are colored in the same color as the existing model, so it's colored by temperature. So if we do change this coloring of these to we color a solid color here, like that. Now you can see, oh, I moved the sphere, that was not my intention. And also we don't need to see the sphere, so we can click away the sphere here, and now you see that the data is the streamlines are visible. What you also can do is that to make the streamlines a bit more visible, we can take these lines and create tubes from these lines, so they get a bit of a thickness. So then we do go to filters here, and I will show you here what available plugins there is here. So this menu will cover the entire screen, and that is all the available filters that you can use and apply to your data. And to make it easier to find, there is a search function here. So you just start typing here. So tube. So there's a filter called tube, and I apply that to my stream tracer here. So now you can see here you have the stream tracer that took the data from the disk out reference, create streamlines, and then I want to create tubes from the stream tracer. So let's see if I just do run here. Then it creates tubes here. I think these are a bit thick, so we change the radius to 0.1. We can do 0.05. And every time I change a parameter, I need to do the apply again, because for certain models, this could be an extremely costly operation. What we can do here is we can color these streamlines by the speed. So let's see, here we go. Instead of solid color, we go to single V, which is for speed. And now you see here, it colored these streamlines using a different color scale. So we can change it here again. So now the streamlines are colored depending on what the speed of the particle is at that point. And what you can do now is, for example, we can change to make the background a bit more visible. We can change the color scale of the main model here to be a little bit more visible. We do the default on that one as well. Right. So now you can, it's a bit more visible. You can also do what I said before. We can make the clip transparent so that we can look through this here. So now you can see here that you can see through the visualization, see the streamlines inside the tube as well. Another visualization you can do is display a vector field. So let's turn off the streams like that. We click on our main model again, and then we create on the filter called Glyph here on the top toolbar here. And Glyph is a special filter that will take and visualize the vector field of the model. So it will place put points in the model and orient a symbol in the direction of the vector that the vector field is specified. So in this case here, orientation array, we select speed, and the scale is speed. We scale by magnitude, and then there is a nice function here in the to calculate the scaling factor automatically. There is 2 arrows that you can click to make it calculate a suggestion of the scale factor here. And here you can also specify, so it will place points by default uniformly in the model, and you can also place the arrows at the elements of the model, but sometimes that is doesn't look so nice. So uniformly distribution is probably better. You can say how many points you want, and let's just see what happens here. So now you can see it created arrows depending on the vector value of the field here. And of course, we can color the arrows of the speed here as well. But these arrows are a bit too clumsy. Sometimes you just want to know the direction. So instead of using an arrow here, you can do a line. Do apply again. We use different coloring here. We have solid color. And we can make the lines a bit more transparent. So you can see through here. So this is the main workflow of ParaView. So that you start with a data model here. You apply filters every step here. You can have multiple filters. I can combine them here, so I can activate my tube again here. And now you can see both vector field arrays and also arrows, and you can also see the streamlines that we created before. And you can turn the other ones off. You can also turn off the clip here and turn on the complete model here, make that transparent so that you can look inside. Like this. So there you have a lot of opportunities to visualize, and it also has a lot of the filters here are quite powerful. So you can see here that there is most of the algorithms for visualization is built in here. But how do you save this model? So if you want to kind of recreate this model, so this model I loaded in a data file, I did a lot of operations, and now I want to save it. You can do that by saving the state. So if I just put some my desktop here, I put here my this one, and by default it's a data file that is PVSM, but it's also possible to create a state file that is a Python file. So I think that is more relevant to this course, so I do that. And I press save here, press OK. And then we do a reset here. Yes. And of course, I want to look at that file. So I open my desktop here, and I created a file called myvis, and I edit that one. So now you can see here, or perhaps you can see, I will do, this is Python code that uses the built-in Python interpreter in ParaView to recreate the model exactly. So you can see it loaded the data model here from a data file here, and here is also where the file name is exactly. And then you provide a lot of properties to your objects here, which control the visualization, and you connect them together. And yeah, you see there's a lot of data here. But basically, this is a Python code that you can run and modify. And at the end here, you can see here that you can run this standalone again. So, for example, if I'm doing this a bit on the fly here, but I think there is a PV Python. Yes, there is a PV Python shell that you can start. And if I go to okay, but now I got to it's not so good use. But what I can do is when I open the file here, you can use that Python interpreter to actually run your file. It contains all the modules that you need. If I go to my desktop here again, and I load my, no, sorry, wrong menu, load state. And you see here, there's myvis here, and I open that one. It will execute that file and perform all the visualization steps that we did before. You can see here, it runs the stream tracer here, for example. Not sure why it takes so long time. And my program crashed. Let's try it again. ParaView. Usually you should get the thing up again, but I don't know why it didn't work now. That was not a good illustration. Okay, I will try a simpler model here again, just quickly, because perhaps there's something in this that makes it not work. What you can do, I create a sphere here. Apply, and I set it to 16 by 16. Like this. And now I try save state again. Python file. And I do okay, and then I do a reset of the model to erase everything. And then you should be able, hopefully it will load it this time. Load state. Yeah. So that Python file contains all the description to be able to do the visualization again. So the state file enables you to save your visualization, but not the included data files. The data files are referenced from this file. So it will load the files that you have selected and run the visualization again. So the next step we're going to look into is how to actually get data into, if you have a Python code, for example, and you want to create a visualization from your data and use ParaView to accomplish the visualization task. And if you look at, by default, ParaView can load a huge amount of data files, data types. So if you open the dialog box here and you look at what kind of files it supports a huge number of files that it can load by default. But if you want to generate the data from your own Python calculations, you need to have a tool. And that tool is what I usually use is a library called PyVTK. That is a non-graphical library that can take data and create a special data file that you can read from VTK with an extension .vtk. And let's see if I can find my notebooks. So, PyVTK is a Python library for creating files that you can use with ParaView. And it supports all the data types I described before. You have image data, rectilinear data, structured grid, unstructured grid, polygonal data, and unstructured grids. You install it by using opening a command line prompt in Anaconda and typing pip install PyVTK. And I will also download here a special module here that we will use in examples later on. So now I download that. So if you look at the first example here, you can find all the examples here in the PyVTK directory here. So the first thing is that you load the module here, PyVTK import star. And then you have to define what kind of data structure you want to visualize. In this case, I will use the polydata data structure. And and usually you define the data by providing a set of points, and you provide a topology for the data. So in this case, there's polygons, surfaces, and you see here that you have 0, 1, 2, 3. So this quad would go from 4, 5, 6, and 7, and so on. So the first part here, this is the coordinates, and this is the topology of the data. And then you have to add, so a visualization is kind of completely useless if you can't provide data to your geometry or your model you want to visualize. So now you have a data structure called defined by polydata, and then you now have to add points. So in this case, the points are connected to points. So in this case, you have 8 points here. And for each point, I assign a scalar value here from 0 to 7. And the nice thing here that you can also, important thing is that you should name your data so that you can find it again in ParaView, because otherwise it's kind of, you have 10 different data points or vectors and you don't know which is which. So it's a good idea to name them wisely. So in this case, the point data consists of scalar values. So you can provide scalar, you can provide vector data, you can provide other kind of data connected to the point. In this case, it's scalar. So now I have a structure. I have point data that I want to add to the point data I want to add to the points of the structure. Then you also have each of these polygons. They are defined by it's called a cell. And every cell you can also add data to the cell. It could be scalar value, it could be a vector. So in this case here, I have added 3 data fields here. So we have scalars. So every cell there are 6 cells here, and I have 6 values here. So these are 6 values here, and I call them cell scalars. And then I have normals here that is for providing shading to this. So this is not always necessary, but these are provided for each of the cell in this data here. And I call them cell normals. And then I also have field data here with additional attributes here that I can visualize to each of the cells around this. And also, not everything is required. You can provide only scalar data to your point, your visualization. You don't have to specify cell data if you don't want to. And then you can create final step before the model is that you create a VTK data object, and then you provide a structure, you provide a point data, and you provide a cell data. And then you can use the to-file method here to write to a file, and you can specify either ASCII, text readable, or binary file format. So let's see here. It seems to be okay. So let's see how the file looks like. So if you look at the ASCII version of this, you can see here, this is the VTK data file here. So you have the points first here, you have the polygons, you have specify how many cell data there is, and so on, and then the data comes here, specifying the entire model. So let's see here if I can download this file. There should be an example 1. Download this to somewhere. Let's see if we can open this with ParaView. File open, and then I think it was done. Example 1 VTK. Let's open that and see how it looks. Same thing here. I need to apply to kind of see this. And it became a cube. And you can see that you have it by default. It sees that there are values attached to the points, and it automatically interpolates those values here. So you can see there are simple scalars is selected for the visualization here. We can see how surface with edges there is basically only 3. There's not many triangles here, but it divides them in triangles. You specified the quads, but it divides them up into triangles. And you can see that the maximum value is 7. If we go back here, you can see, yeah, the maximum value we provided for the points were 7, and the lowest is 0 here. So it seems to read the data correctly. You can also visualize the cell values here. So let's see cell scalars. And now you see that it colors each of the cells a single color of the value it has. And you see here that it's from 0 to 5 because we have 6 sides and there are 6 colors. So this is the way you can generate data from Python, which you can read into ParaView and use. And I will illustrate with some examples here what you can do. So we'll take a 15-minute break, and then we continue after at 14:15. Okay, so let's continue with some more examples here. You have it's also possible to create data from structured points. That means that you specify a structure that consists of 3 columns, 4 rows, and 6 depth. And then you provide point data to that by just listing the values of each data point in the structure. And then you can write it out again. And if you look at that, we'll download that file. So now we have outline here. We do surface with edges. So now you can see here you have 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 data points in the structure. And you can, as you can see here, you have 3 by 4 by 6, and then you have all the data points here. And we can then color this with scalar 0. And now you can see that you have values as well here that should correspond to the ones you provided in your data structure. That's one way of doing it. Another way that you also can do is that you can create VTK data. You can load an existing data structure here. So in this case, we load VTK example 2, but we only load the structure. We don't load the data points. And then we specify a function here, and then we add data here by computing the function in this case. And if we download that, do a reset again, yes. Then we open the VTK file again. Okay. Same structure, surface with edges here, and we change the color to X, Y times Y times Z. And now you see here, it computed the values of that structure based on that function. You could also have created only the VTK section up here without the point data, and then added the point data afterwards here using this command here. There are some other exotic examples here. I will skip those. I will go to example 7 here. This is a way of visualizing unstructured grid. So an unstructured grid is can contain any kind of geometric primitive. So in this case, you can see here that we have points that we take from this list here. We have hexahedrons here that references some of these points here. We have a tetrahedron with the topology here. We have a polygon. We have a triangle strip, a quad. A quad is a four-sided surface. And then we have a triangle, two triangles, and a line and a vertex. So you can see here you can add a lot of different and combine them into that's why it's called unstructured. You can have a mix of different primitives in this data structure. And then we provide some point data to each of the points here. So the points here will take the data from the vectors and also from the scalars. In this case, it's just a scalar from 0 to 26. We can look at this in VTK as well. We will download that. Go back to VTK, do a reset like this. We open, downloads, example. Do an apply. Now you can see here we have a mixed bag of things here. So if we just do a solid color here, we do a surface with edges. Why didn't? So you can see here that there is a point here, and there is a line, and there are triangles, there are quads, there are tetrahedrons, and there are blocks. So you can see that you can combine data in different ways, and you can still have it plotted the scalars for each of the points here. So you have all of them share the data that is provided in the VTK file. Let's see if we do vectors here. We can do so with the scalars like that, and we add glyphs here, and we use the vector data here. Apply. And you can see here that there are vector data available in this data set as well, and those are plotted in each of the points here. So by using PyVTK, you can create any data structure and then any visualization and provide any data to ParaView from your own code. So let's see, we'll do reset again. So that is unstructured grid. So now I'm going to show you some more advanced ways of using ParaView. So you can compare this to if you have data that you want to visualize, but this format is not supported. So in this case, I have data consisting of vectors and coordinates with so simulation data from a flow visualization. So if I run this, you can see here that it contains first header here with the data, so X, Y, Z, and you have U, V, W for the vectors. There are some other points. This is a grid-based structured data here with 96 by 65 by 48. And then basically the data is listed here, follows here, and the entire file is like this. So how do we do this in Python? So first thing we need to, for efficiency reason, we use NumPy. So we import NumPy. We use PyVTK, and we, instead of using from in PyVTK import star, we do a better way of doing it using the as VTK. So first we load the data in just a raw NumPy array. So in this case here, there is NumPy has a function called load text, which you can load text files from with a certain structure. So it will read each row, and every data point is added to this and returned as an array. And you can see also here that I skipped the first two lines. There is an option here that will skip over these two first lines that we are not interested in reading. So we just start reading from the second and third row. Then we need to convert the data here. So we need to have one array with the points and one array with the vectors in it. So in this case, I do some indexing here. To the points are located in columns 0 to 2. So 0, 1, 2, that's the points. So in this case, I want all rows and 0 to 2 columns. And one problem with the VTK, PyVTK module is that it doesn't take NumPy arrays. To solve this, we use a method on the array called toList that converts the array to a list, which we can provide into the PyData classes. This is a bit inefficient, but it's the only way to do this. And then the vectors are all the rows starting from the column number 3, going up until the end of the column here. So now we have two data structure points and vectors. So now we provide the point data here, and we add the vectors to each of the points. And then we create the data structure here. So we have a structured grid, and we saw from the header that the structure was 96 by 65 by 48. And then we add the points to this as well. So and then we add point data for each of the points in the data structure. And then we write a file here, UVW, to an ASCII file. So hopefully this will work. We will read it in. And now we should have a UVW.vtk file in our file section here. Yes, we have. So we download that file. It's a bit larger than the files we had before, so it takes some time. Like that. Go back to VTK. We open the file. The first thing I do when I load things is just to kind of click the apply button to see what does it look like. And it looks like a box. So we now it says it's visualizing the outline. And outline is, if you have large data structures, sometimes it could be beneficial for efficiency or modeling that you only draw the outline of the model instead of the entire data visualization. So surface with edges. Okay, so it seems to be the data we needed. And then we can also quickly just show, instead of the surface, and then we say that we want to plot the magnitude of the vectors as a scalar value here. So you can see here that the vector field varies a lot inside this structure here. So, but to illustrate that we have a vector field, we could do vector field visualization. So if we scale this to make it more transparent here, we can add a glyph visualization here, and we orientate them on the vector here, and we scale the array, and we auto-calc this, and we use lines here to visualize the flow. So now you can see that we have the vectors, we can scale them a bit. And we can put them as single color as well. Solid color, see them here. Make them a bit transparent. So that is the vector field. We can also do streamlines. And then we point cloud here and we scale it up to and then we do oh, sorry. Number of points here, I think we'll do 200 stream points to follow. And then we apply. And now we got some streamlines here, and we turn the glyphs off here. Now you can see that we have nice streamlines here. And as you remember, we can give the streamlines thickness by using the tube filters. We go tube. And then we apply again. Oh, a bit thick. We do apply like this. We can make them a bit shiny as well by adding the specular factor here. I don't know if you can see that so good, but so this is a way of. So now we have taken a very abstract data file, text file, put it through some filters in VTK, and made the data more visual to see what actually happens inside that data structure. So this could be a snapshot from a simulation or anything, and you can put that in here as well. Also, if you have multiple time steps that you have in a simulation, you can also save each of these time steps as a separate file with a number appended. And then ParaView can automatically load all these files, and then you can animate them between the steps. And I can show you how this could look like. I will do a reset. There is this example visualization in the help section here. We can take this one here, for example. So this is a finite element simulation here. And on top here, you have controls here for controlling the step here. So you can move back and forth in the simulation here. And each of these steps could be a single data file that you could that it loads the data. So if all the data is stored in finite element model 1, model 2, model 3, it will load all of them into ParaView by default. And now I have another example here. So I have this is a elevation model from I think it's Grand Canyon or something, where we have elevation data, and that is in a binary file. So what I need to do is load the data into memory, and we need to do some manipulation here. So the elevation data here is binary. I used RB here, B for binary, to read. And I also need that there is a header information in this file that is 268 bytes long. So we need to move the pointer in the file a bit so that we don't read the header data as elevations. And then there is a way of creating arrays from a file in NumPy. And now we need to specify what the data type is to be able to read a binary file in NumPy. So in this case, from file here will read from the file object, and you specify here the data type that is supposed to read. And now we know that this data structure consists of unsigned bytes, and we need to tell that to NumPy so that it can read the data correctly. And we also know that the data is 400 by 400. So this is a two-dimensional grid. And I will plot it here in this as well to kind of show how it looks like in ParaView. So you see this is the elevation data here is from 0 to 400, 0 to 400. And the color here indicates the elevation. So I created a file now, a VTK file called elevation.vtk. It's there. And we download that file. Go back to VTK. Elevation. So by default, ParaView sees this as a basically image data. So we have to switch to 3D so that we can see this in 3D because we want to do some manipulation of this file. So what we do in this case, what we want to do is to warp this plane to something three-dimensional. So what we want to do is we want to warp it by a scalar. So there are two ways of warping a data structure in ParaView: by a vector, which can be very interesting if you have a finite element model. You can use warp a vector to display the displacement of a model, because the displacement is often provided as vectors, and then you can displace the structure by the vectors. But in this case, I just want to have create a three-dimensional view of this 2D data. So we do warp by scalar. And let's see what happens if you just press here. Okay, so sorry, perhaps a bit too much. So we change here automatically. Like this. And now you can see here that we can see the triangles here. So we need to somehow create smooth this surface out, and that can be done by creating vertex normals, it's called. So I do a source surface. Generate surface normal. So by default, the triangle, the lighting is calculated by the normal to the triangle plane. And if you want to have smooth surfaces, you need to calculate the normals on each vertex or coordinate. And you can do this automatically by this command called generate surface normals here. And then we do apply here again. And now you can see that now it's smoothed out the surface here. It actually didn't smooth out the actual points, but it smoothed out the way it's calculating the lighting here. So now we can do some specular here, so you can see the actual surface here like this. And I will also change, do something like more like surface model like this. So there's no scientific data value in this color scale. It just looks nicer this set. So, but now also we took a really bare binary file, 2-dimensional data, and created something that makes more sense to look at. You can actually detail and rotate this in different directions. And one cool thing with ParaView as well, it actually supports VR as well. So you can actually have use Oculus VR glasses to actually look at the data and take this in your hand and kind of examine it very in detail. So it's a powerful tool. So let's do a reset here again. Then we have the final example here is a volume visualization. So that is, now we did 2D data, we do 3D data. So to just illustrate this, I have a special module here that generates Perlin noise. That is a special kind of frequency-based noise that you can use to create more smooth noise data. In this case, I create a cube that is 128 by 128 by 128. And this is the size of the parameters here. So, and then I provide that to a point data structure. And this reshape here is just that it's provides them in a single data array, not a 2-dimensional array. And then I create structured points 128 by 128 by 128. So let's run this. And now we should have a Perlin VTK here, which I download. So volume data can be visualized in different ways in ParaView. I will show you 2 ways of doing that. So now it's Perlin here, so I go back to VTK, my ParaView, and then I go to downloads, and then we'll see Perlin. Just open the data and take a first look at it. Nice box. We do surface with edges here. So you can see here now how many. So 128 by 120 is actually quite a significant amount of data. And if we just plot the scalars here on each point here, you can see the Perlin, typical Perlin pattern here of the data. And if we do a surface visualization here, you see like this. So what we can do now, there are 2 ways of visualizing the data inside here. We can, there are more ways. You can, for example, if you want interesting to look inside, you can do a slice like this. Now you can see inside here at a certain point of the data. But sometimes it could be useful to kind of get the feel of the structure as well. And then you can do isosurfaces or contour plotting in 3D. So there's a contour filter here which we apply. And by default, you can set what kind of values we want to look at. So for example, if you want to look at all the 0 values in the structure, we can change here to 0. And we apply. So this is all the surfaces that represent the zero values in this structure. We can do some better lighting here, that you can see how it looks like. It's also possible to define a range. So let's see here, going from -1 to 1, and linear generate. And so it generates the different surface values you want to look like, and then we apply. And here you can see the different surface values here that we have in this volume. But there is even more. This is kind of a bit hard to look at, and if you want to kind of have a feel of the structure inside, you can also do a volume plot. So I will turn that off. I will do volume visualization here instead. Yes. And now you can it looks kind of the same, but you can set the transparency of different. You can in this case I can, for example, make a step function here. And actually make certain things transparent and different ways to kind of see through the structure. This was not the best example here, but so you see here that the things are a bit transparent here. Let's see if we can set another. This is what's called a volume visualization. Let's see if I can pull that down as well. And you can also do shading here, so you get even more structure here. There is also a way of actually so now this is a hardware accelerated render, but you can also do ray tracing. So you can enable ray tracing. Oh, this was let's see, shadows. Or refresh the machine again. That was probably too much for my computer. But all of the functions that you have in ParaView can actually be, if you want to do a more advanced visualization, you can turn on the. Why can't I kill this application? But that was a way of generating volume data at least. So that was all the things I had for this lecture. So I will stop the recording.